Hello and welcome to episode 17 of How to Code Games in BBC Basic. In this video we're going to be taking a look at the InKey function, which can be used for detecting user input, and we're also going to explore the keyboard buffer. Okay, so in this video we're going to take a bit of a closer look at this procedure here called ProcKeyTest. Now you'll remember from previous videos in this series, if we just hop back to the main sort of display invaders procedure here, it's one of the procedures that gets called as part of this larger loop within which we've already seen proc invader and how that displays the alien grids on the screen. But at each start of the sort of repeat iteration, you'll notice this call to ProcKeyTest. And that's very important because essentially what this procedure is all about is checking whether you, as the player of the game, have entered any keys that the game needs to be aware of. And that's really what ProcKeyTest is doing here. It's checking for the pressing of particular keys. And you'll notice that it's very straightforward logic. If a key, which we'll have a look at in a minute with this InKey function here, but it tests for a particular input, and depending on what that input is, it then calls the corresponding procedure that it needs to call on the basis of the key. So if you press a key that indicates you want to move left, then it calls the procedure to move left. Likewise, if you press a key that indicates you want to move right, it'll call a procedure that moves your space right. Alternatively, if you hit the fire button, it calls a procedure to fire a missile, although it has to check, of course, whether or not there's already a missile in flight, because in this particular game, you can't have more than one missile on screen at any given time. So if you've already hit fire and fired a missile, and that missile hasn't actually hit the top of the screen or collided with one of the cosmic invaders, then it won't call proc fire, even if you do press the corresponding fire button. And you'll notice that it runs this proc key every time the master loop is called, but inside here you've also got another loop, and this is to control the pause and unpause keys. So here it's saying, well, if you've pressed the pause key, which is indicated here, then essentially stay inside this repeat loop until you press the unpause key, which is indicated here. So if you go inside ProcKeyTest and you happen to press the pause button, then you'll essentially stay inside this procedure until or unless you unpause. Now we'll take a look at this in a little bit, but essentially here what we're doing is before we exit the procedure, because bear in mind the procedure is just testing for key presses. It may be the case that none of these keys have been pressed. So what it does here is it flushes the keyboard buffer. And we'll take a little bit closer look at what that means in a minute, but that's essentially what this rather cryptic code is here. This fx command is essentially flushing the keyboard buffer before then leaving ProcKeyTest and returning to the procedure that we looked at previously, which if we just quickly hop back, you can see it'll test for keys and then jump into the rest of this master procedure. Now, all of this is happening incredibly quickly, which means that actually the computer is calling ProcKeyTest every few milliseconds. So, you know, as a human being, it's indetectable to you. You don't realize that actually what the computer is doing is running ProcKeyTest and then running a bunch of other instructions before looping back round to check for key presses again. From your point of view, it kind of feels like it's always monitoring the keys that you're pressing. So what we're going to do in this video is understand a little bit more about how it's actually doing that in practice. So I've got a few sample programs here which we're going to run in the old BBEM emulator, and they'll hopefully make a bit more sense of what the InKey, or InKey as I used to think of it as a child, the InKey function is actually doing. Now, strictly speaking, there are two variations of the InKey function. There is the one that we see here, which is InKey just as the letters INKEY. There is also another variation which is the same but with a dollar sign at the end. The difference between the two is that InKey without the dollar sign will return you a value of the key pressed in terms of its numeric value. So you'll remember from your basic lessons that every value in basic has every character I should say in basic has a corresponding number. Oh, sorry, I should probably done that properly. Uh, Sorry, I'm forgetting my basic here. Why am I getting no such variable? Yes, of course, because I haven't put any. Nope, that's a type mismatch. Let's try that again. There we go. We got there eventually. So yes, this function, as you know, converts the sort of the real world character, if you like, the letter L there, into its numeric equivalent. And then likewise, if I call this function with that number, I get the corresponding letter. So the InKey function is one that will return you a value of 76 if you press the L key, whereas the InKey with a dollar sign at the end would return you the actual L character. So it's essentially deciphering the 76 for you. But the in key without the dollar sign has a little bit more flexibility than its corresponding twin, the in key dollar function, because in key without the dollar sign also has the facility to effectively wait for a particular key to be pressed. So it can be used as a true or false scanner, and that's actually the way in which it's being used here. And that's also why the values are negative values. So these values here, the minus 98. So minus 98 is not the corresponding value of Z, because for example, if I do I'll get it right this time. If I do Z here, it actually is a value of 90, not minus 98. So the fact that it's using the minus versions only comes into play when you're using the in-key function as a true or false test rather than as a means of scanning the keyboard buffer. So let's look at the difference between those two so that we can make better sense of how they're being used in this program. So I'm going to load a program I've already written, very simple program here, and we're going to run it. So it says press a key or wait, so I'm going to press the letter P, and it tells me, boom, you pressed 80, which is the ASCII, obviously corresponding version of P. You can actually see it here in the print text, so I've put in the character string function here to decipher the value that InKey has scanned. Now, if you look at the guts of this program, it looks a little bit different because actually what it's doing here is I'm assigning a variable called key dollar. I'm assigning it the value of InKey, and then I'm putting brackets 500. Now, the brackets 500 is essentially telling the computer or telling the program to wait roughly 5 seconds. It's slightly imprecise because of the dependency on crystal circuitry and such, but effectively 500 is broadly speaking 5 seconds. What it's saying here is I want to give the user the ability to have some time to hit a key before I then return what it is that they've pressed. So if I run the program and don't actually hit any keys at all, the 5 seconds will elapse and it'll say you press nothing because the in-key function in that case will have returned a value of -1 to our variable key dollar, and that obviously goes through the if statement here and comes out with else you press nothing. So that's how the in-key function can be used as a means of checking what value somebody actually pressed. But the way in which it's actually used here is slightly different. It's not asking, tell me what did the user press. The game is actually written from the alternate perspective, which is there are only a certain set of key presses I am interested in, and unless the user presses one of those keys, I'm not interested. So if you sit at a game of Cosmic Invaders and you hammer away at the P and the W and the H and the G and so on, the computer doesn't care because it isn't interested in those values. It's only interested in a very narrow subset. And that's why you can also use the function in the sort of flip side, which is tell me whether or not a given value has been pressed, which I am expecting. If it has, do something, and if it hasn't, don't do that thing. And that's what we're going to see in the next program. So if I load InKey 2, and actually we'll just clear the screen. Now here, this is slightly different. What this is saying is when I run the program, I'm being given instructions, kind of similar to when I run the game. And it's saying you can press Z to go left, X to go right, or Shift to fire. So if I press Z, you can see, oh, it can see that I've pressed Z. And if I press X, it goes, oh, you've pressed X. And if I press Shift, it says, oh, you fired the missile. And, I can hit these in any combination, ZX, 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 Shift, Shift, Shift. In much the same way as if I was doing a sort of a keyboard scanner for logging what a user is doing in the game. That's kind of what this would look like. Now, you've probably also picked up on the fact that although I'm only hitting, and trust me on this one, I know you can't see my fingers, but I am only hitting the letters Z and X very gently once, you're actually seeing a response sort of multiple times. Now, the reason for that is because there is such a thing as a keyboard buffer. And what the buffer does is it tracks key presses and kind of puts them into an area of memory so that it can allow for longer or shorter durations of key press. And you'll know from more advanced games that you'll have played on the BBC Micro that certain games, particularly games with quite fancy physics in them, will behave slightly differently if you hold keys down for longer or shorter periods. If you think, for example, of a game like Starport, which I reviewed recently, when you press the jump button in that game, if you hold down the jump button, he actually jumps for a longer distance than if you just tap it slightly. Now, the keyboard buffer facilitates that kind of thing because it doesn't just say, okay, you press this key once. What it does is it tests for how long was the key pressed down for. And it's actually very difficult to simulate just pressing it, once. Like if I try just to tap the Z, I still get 3 Zs coming back there, or tap the X, well, I managed to get 2 there. So that's about as close as you're likely to get with clumsy human fingers. But that's what the keyboard buffer is there for. It's to allow for this idea of checking how long a key has been pressed down for. Now, I dare say it has other uses as well, but when it comes to coding games in particular, especially games with, as I say, maybe a bit more advanced physics, it's very, very helpful. Now, at the same time, it can also be a bit frustrating for a programmer because if you've got this buffer and you're only really interested in one particular key press, you don't necessarily want any other key presses to come flooding back at another point in the program. That's kind of like you've pressed a key at a given point, it's put it onto the buffer, and then you've exited that procedure and gone on to do something else. And when it then perhaps calls the InKey function, what the InKey function is doing each time is it isn't actually going and checking the key. It'll go and first of all check to see, oh, what's on the buffer. If there's nothing on the buffer, then it will default to what you might have pressed. And we can simulate that in BASIC as well. I'm not going to do that in this particular video, but there are certain tests you can run. If you go and have a look at Richard T. Russell's excellent documentation for BBC Basic, you'll see that he's got a short sample program there that shows you the difference between clearing and not clearing the keyboard buffer by running a series of InKey commands. And if you press a key and you don't clear the buffer, then the next call to InKey will return the value that's in the buffer rather than the next key that you press. So that's what this fx15.1 command here is doing. What it's trying to do is safeguard against the idea of other key presses interfering with the running of the program elsewhere. So within ProcKeyTest, we're only interested in the pressing of Z, X, Shift. And obviously, if the user chooses to press the pause or unpause buttons, which I think is P and U, then that will cause the procedure to go into an indefinite loop until they unpause. In fact, I think I've coded this little sample program with the unpause of U, and that now takes me out of my my in-key loop. So I'm not checking for key presses anymore. So that's effectively what's going on here. Now, it's got a little bit more advanced in the sense that the program tries to guard against you pressing Z and X at the same time, because bearing in mind, obviously, how a keyboard buffer is working here, if I was to hold down, in fact, I can show you, if I run this program and I hold down Z and X, you can see that it sends a very, very confusing series of instructions to the program. Now, in this case, I'm just logging my key presses, so it doesn't really matter. But if you imagine this taking place within Cosmic Invaders, that's a very confusing series of responses. And actually what you would end up doing is never being able to move left or right, because if you hold down Z and X, it's just going to keep shifting between proc move left, proc move right, proc move left, proc move right, and the result is that you're not going to go anywhere. So what this is doing is it's just guarding against dual key pressing. So it's saying that if you've pressed Z, but there isn't also an X in the buffer at the same time, then you can safely call proc move left. And likewise, if you press X and there isn't also a Z in the buffer, then you can move right. If the user is foolish enough to hold down both keys, the game will just sit there and not do anything because it can't process these conflicting commands coming from the InKey function. Obviously, the missile doesn't have the same issue because you can certainly press Shift alongside Z or X, and all that'll do is cause the command to fire the missile to go into the buffer, and it'll obviously, having processed whether or not you pressed Z or X, there's no go-tos going on here, so it's not skipping to the end of the procedure, so it's running these in sequence, checking whether you pressed left, checking whether you pressed right, and then checking whether or not you've fired a missile. And obviously, as we already said, making sure that there's not already a missile in flight, because if there is, you can't call ProcFire again. We've talked about the inner loop here, we've talked about flushing the keyboard buffer, and that takes us to the end of ProcKeyTest, and then we return to our display invaders master procedure. In previous videos, obviously, we've already looked at how the proc invader function is working to display the missiles on, to display the cosmic invaders on screen, I should say. What we'll probably take a look at in the next video in the series is how the firing of a missile, how the mechanics of that work, because that's quite clever, and it's quite important to the overall functioning of the game. There is a reason why the game actually limits you to one missile on screen at a time, and that's because it needs to be able to track the positioning of the missile on every iteration of the game's master loop. If you were to try and introduce multiple missiles, which of course plenty of other shoot 'em up games for the Beeb did have, the difficulty that you have in that case is that you've got to then be able to track multiple missiles on screen for every iteration of the game loop, which is not impossible to do, but it does make the programming of the game that much more complex. And certainly for a relatively simple, albeit very cleanly coded game like this one, it's just more straightforward to limit the number of missiles on the screen, and that's what the programmer has chosen to do in this particular game. So we're going to leave it there for this video. Hopefully that's taught you a little bit more about InKey, about the keyboard buffer and exactly how that works, and how you can use the InKey function in two different ways, depending on what it is you want to do. And 9 times out of 10, I think it's fair to say, when you're programming games in particular, what you're interested in doing is testing for particular key presses rather than necessarily being interested in the full ASCII key set available to you. And that's why the InKey function is being used in this way. If you're really interested to learn more about InKey, I do recommend that you go and have a look at Richard Russell's documentation. As I say, he's got some interesting test programs for it. The full BBC Micro documentation, including the user guide, actually gives you a nice lookup of all of these negative numbers because they are different from the ASCII equivalents. So if you need to test for a particular key press, perhaps your game wants to use the letters Q and W, you can look those up and see what their corresponding negative values are in the user guide. But that's it for now. So thanks for joining me for this. Well, it's been a while since I've done one of these BBC Basic videos, but I was prompted to do one again when I realised just how much time had passed since I did the last one. So I hope you've enjoyed it and that you'll join me for the next one in the series. And until then, goodbye.